Example 75. Use the z-table to find the probability that a standard normal random variable is between 0 and 1. What should it be using the empirical rule? Okay, so when you read example 75, we're trying to find an area under the bell curve, and we're going to use the z-table to do this. And then they ask us, when we're done, to approximate what the area would be according to this empirical rule we learned earlier on in the course. So here's how you do a problem where they want us to use the z-table. You want to follow a set of proper steps. And in my opinion, the proper steps are to draw a bell curve. And then from there, I want you to label a z-axis. So this is a number line running underneath this drawing. And you'll center that bell curve at 0 on this number line below. So what we're doing is we're finding the area under the bell curve according to the location of a z-score on this z number line. Now the problem asks us to find the probability that a standard normal random variable is between 0 and 1. The way we write that statement in probability is to put a 0 and a 1 inside parentheses and then put a z between them. And then you use less than symbols surrounding the variable z, because what this is saying is that the z value we're looking for is bigger than 0 but less than 1. And that's the same as saying it's between 0 and 1. So whenever you want to say something is between two numbers, you're going to put the variable in the middle with less than symbols surrounding it. Okay, so between 0 and 1, well, here's 0 on the number line, and 1, of course, would be to the right because positive numbers are on the right of 0. I draw a line on the curve above 1 because that is the location where 1 is on the curve above. That's where 0 is. And if we're looking for the probability that z is between the two of them, we should shade between the two numbers. So we're going to actually draw shading on our picture so we show what area we're looking for. Now from here, our goal is to go to our z-chart and to look up the 1 on the z-chart to figure out what area corresponds to that drawing here. Now the way the z-chart works is pretty interesting. If I look up a number on the z-chart, it'll always give me the area from that number to the center of the curve, always. If I look up a number on this side, it'll give me from that number to the center of the curve. So we always get the area from the number we look up all the way to the center of the curve, which in this case is 0. So that's how the z-chart works. Now it turns out if we look at our drawing, if I looked up 1, I would get the area from 1 to the center of the curve. And that is the exact area we have shaded. So it turns out the z-chart does this problem perfectly. If I look up 1 on the z-chart, it's going to give me the area I'm looking for exactly. So all we have to do to finish this problem is to go to our z-chart, look up this number 1, and get the area to the center. Now one little detail, the z-chart uses numbers with 2 decimal places after the decimal point. So I'm really going to be looking up 1.00, 1.00. And the way the z-chart works is that these two numbers will be in the leftmost column of the chart, and this last number, the 0, will be across the top row of the chart. So we're going to look up 1.0 first and then go over to the 0 position above that, and you'll see the number in the chart. This is going to be hard to explain without looking at the chart, so we're going to do that right now together. Let's go to our z-chart and look up 1.00. Okay, so now we have to look up 1.00. In this first column, we find the first 2 digits of our z-score. So we're looking for 1.0 first. So we find 1.0 here, right? 1.0 there. And then the last digit 0 is found here. Notice at the table, or on the table, for this top row, the first 2 digits are always 0, 0. That's because they're letting us know we're not interested in those digits. We use this top row here to get just the last digit of our z-score. So if your last digit of your z-score is 0, you're going to be in this first column. And for 1.00, the answer is 0.3413 then. Okay, so we're back from our z-chart, and we get the answer for this space here, 3413, 0.3413. So in other words, that area is 34.13%. And since that's the exact area we were looking for, that's the answer to our question, right? 34.13%. All right, now once we have that, and by the way, just a little side note, you notice how I drew the area from my table in the space that the table gave me. So the table was giving me the area from here to here, and I put my area where it belongs on my drawing. If that area lines up with what you shaded, you finish the problem. If it doesn't, you're going to have to do something else to get the answer to your shaded area. Now in other problems, we'll see that that's going to be necessary at times. So a good habit, though, again, is to get into the habit of putting your area from the table on the drawing where it belongs. Because sometimes you won't have this spot shaded, but that's the only area the table gives you, and you'll have to do a little arithmetic to figure out the missing area. So it's important that you get in the habit of putting your decimal answer from the table on your drawing wherever it belongs, right? Don't put it in the shaded area automatically. Put it wherever the table says it goes, and then if it lines up with your shaded area, you finish the problem. Like in our case, we looked up 1. 1 was the area from here to here on the table, so that's where I put my decimal answer. That happens to line up exactly with where I shaded on my drawing, so this is why this is the answer to the problem. There'll be times when we might have just this part shaded, the tail, and we'll still get this area from the table. In that case, we'll see that the decimal number is not on our shaded spot, and we'll have to do something to figure out what the shaded area is. So we'll see examples like that in a moment. That's probably better done with an example than explained here in this problem, so we're going to move on. Last thing I want to talk about, though, is this phrase here. It says, what should it be using the empirical rule? In other words, what should this area have been if we looked at the empirical rule? Well, the empirical rule said that from -1 to 1 on the bell curve captures 68% of the area. So according to the empirical rule, half that distance, in other words 0 to 1, should have captured only half of 68. So this should have been 34% approximately under the empirical rule. And of course, it's very close to that number from the table. So when the empirical rule said that this space here would have been 34%, they weren't so wrong, right? They were only off by 0.13%. So that's why the rule says approximately 34, because it is approximately 34.